morning, everyone. Happy Halloween. So for today's lesson, we're going to start off with a do now. So we're going to work with partners for this, or a group of three, however many can fit to one index card. So as you can see, there's an index card per every few people on your table. We're going to work with the equation y equals 4x minus 10 and see if your coordinate pair, or your point on the index card, makes y equals 4x minus 10 true, or makes it work. So you can use the substitution method if that works for you. Whatever method, however you feel best fits. So go ahead, take a minute, work with your partner, see if your coordinate pair makes the equation true. And if it's true, raise your hand and I'll call you up to the board to plot the point. Okay, take a minute or two. If anyone needs help, feel free to raise your hand and you can come over. Oh no, there should be an index card on everyone's table. If everyone sees their index card, don't touch the papers yet. My bad. Oh, is it true? You can go up to the board and plot your You plot the point on the index card. Exactly.
They will have like a picture one.
Alright, so if it's true, you can go up to the board and plot your point.
Oh, that might work, but yeah, sure, work.
Okay, great. Okay, so if I can just have everyone's attention up onto the smartboard over here for a second. Can anyone tell me what the points are starting to look like? Anyone give me a shape?
A line.
A line, great job. So that's going to be really important in today's lesson. So for today's lesson, we're going to be focusing on how many solutions there are for a linear equation. We're going to be examining that. So we're going to work with partners again, and using the same exact skills you used from the do now, you're going to try to work with your partner or the group and find 5 points that make the equation x plus y equals 12 true. So a point is that exact coordinate pair, x comma y. So go ahead, try to find an x value and a y value that make this equation true. Try to find 5 of those. Go ahead, take a minute, and if you got one, raise your hand. Once you have a point, can someone raise their hand? Anyone can tell me? Allie? 10 and 2. 10 and 2, great. You want to come up and plot it? Wayne?
1 and 11.
1 and 11. You want to come up and plot that? Okay. Anyone else? Another point? Natalie? 3 and 9. You want to come up and plot that one?
3 beautiful everywhere.
No.
I don't know what it's called.
Oh, you can go.
Don't get it wrong.
How about one more point? Anyone have one more? Brendan?
75.
Perfect.
Right.
Alright, great job everyone. So again, if we can just look at the smartboard, what shape do all these points make? A line, great job. So in today's lesson, one of the big main questions is, are there an infinite number of solutions to equations, or are there finite? Does anyone think they have any guesses? Are there an infinite number of points we can plug into x and y, or are there finite? Brendan?
I think there's an infinite amount.
Think there's an infinite? Does anyone agree with him? Yeah? Does anyone not agree with Brendan? Nice. Okay, you guys are right. There's an infinite amount of solutions, such as decimal points. You can plug in everything that fills say for this equation like 11.1 and 0.9, and that makes 12, and that's an x and a y coordinate. Does that make sense to everyone? Yeah. Okay. So these are just a few questions just to review on your knowledge that you might have learned last week when we reviewed in class. So can someone just explain to me which axis is the y-axis and which axis is the x-axis? You can use the words vertical and horizontal if that helps. John?
The x-axis is horizontal and the y-axis is vertical.
Great job. Can someone tell me what the point 0, 0, what the name we give to that point is? Allie?
The origin.
Great job. What variables do the two numbers in that coordinate pair on each of your index cards, what do they represent? Anyone? Natalie?
The x-coordinate and the y-coordinate.
Great job. And if someone can just give me, when they looked at that coordinate pair or that point, what process went through your mind when you said, oh, I have to go plot this now? Brendan?
Oh, well, the plane's got to go on the runway and then it takes off.
Great job. Exactly.
That's it. I'm telling you, that's it. X-axis, Y-axis.
So first you go across the x-axis, or the run and rise, however you like to call it. Or the plane taking off on the runway and finally going up. I like that. Okay. So as we've seen in the two graphs that were on the smartboard, a linear equation, what form of a graph does that mean? Now, Allie? A line, great job. So take a minute or two with your table and just evaluate these four graphs, figure out which graphs are lines, and I want you to look at the equations. Might be a little hard to see, so I can put it up here too. Look at the equations and see what makes the equations of whichever graphs you choose to be lines different than the equations of the ones you choose not to be lines. So just take a minute or two and evaluate the graphs. Figure out which ones are lines and what makes them different. I like that. Okay, can anyone tell me which ones are equations of or graphs of lines? Alphonse?
1 and 4.
Great job. 1 and 4, does everyone agree?
Yes.
Okay, sweet. So does anyone know maybe why those are equations of lines versus the other two, 2 and 3? Natalie?
The x and y intercepts are to the first power.
Perfect, that's the exact answer. I was looking smart. So what is a linear equation? It's an equation whose graph is a line, which we figured out from all the problems. And the variables x and y must be raised to the first power. Now, when something is raised to the first power, it's just the variable. Some might confuse that with 0, but there's an imaginary one there. For example, if we have an x, wherever we have just a plain x by itself, there's always an imaginary 1 in front of it. It's the same thing for the power rule. So there's always just an imaginary 1 up in the little corner. So knowing that, can someone tell me which of the following equations are linear? Looking at A, B, C, and D. Knowing that both x and y have to be raised to the first power. You and John?
A and D.
A and D, great job. Does everyone see that? Does anyone not see it? Feel free to ask. Okay, great job. So everyone can take out the worksheet on their table. Now it's the one paper that's not stapled. So the directions for this, yes.
Do you have any more worksheets?
Yes, I do.
Just somewhere in here.
Perfect. Thank you.
Thank you.
You're welcome. So the directions for this worksheet, if everyone just wants to look at it real quick, is to match each equation with the correct graph on the side. So use those same exact skills that we use, just in a reverse order right now. Maybe you can plug in points to find a point on the graph that'll match with the equation. That might be your best bet. Or if you have a different way of solving it, go right ahead from prior knowledge if you guys know anything. Yeah, so if you need any help, just feel free to ask your partner, your table, or you can ask me, myself. Yes.
Oh. And then you just plot
And
it.
then you can just plug it in, see which one works for you. You can also look for the slope if you know how to feel free to raise your hand.
No, I'm so serious.
Yes.
Okay.
Okay, so what
Is
you
this one E?
It's okay. You can take points and plot them. So if you want to just look to see like where there's an obvious point.
Okay.
So for example, for here, you can see that there's this point right here.
That's 2.
Crosses exactly at 0, 2. So then you're going to want to plug them into each one.
So like plug random numbers?
Yeah, pretty much.
Oh, man.
See which graph matches up.
Okay, I'm gonna choose B. No.
Does anyone think they have at least one answer? Anyone? Do you have a question or?
I think I have an answer.
You think you have an answer?
I think E is graph 2.
Perfect, great job. E goes with graph 2. Awesome. Does anyone have a different answer?
I think C would be graph 1.
You think exactly, C goes with graph 1. Great job. Anyone else have any other answers? No.
I think D goes with graph 3.
D goes with graph 3. Awesome.
Oh, C goes with
2 more left. Anyone have any other answers? Yep. Angelica. 4 is A. It's okay.
So 4 is B?
Yeah.
Oh, okay.
Okay.
That's fine.
So if everyone wants to just put that to the side for now, if you have any questions, you can come up to me after class or ask me tomorrow, or ask your partners. So just as a little exit ticket, you don't have to write this down, just as a review for yourselves. Can someone just reiterate to me what a linear equation represents? Does anyone remember from the lesson? John?
Line.
It represents a line, exactly. Can someone tell me what powers x and y have to be raised to? Brendan?
First.
The first power, great job. So how many solutions are there to a linear equation? Wayne? Infinity, great job. And how can we graph a linear equation? Someone want to just tell me very informally, Brendan?
Plotting X and Y points.
Exactly, plotting the x and the y points. Does anyone have any questions? No? So for your homework, you have that other sheet of paper that has 6 graphs on it. What you're going to do is you're going to look at the point, just like we did in the do now. You're going to see if the point given for number 1 matches or makes the equation true, the given equation. So there should be 6 points, 6 equations, 6 graphs. If the coordinate point makes the equation true, you're going to plot that point on the graph, just like we've been doing the whole time, and you're going to circle a yes. If the point doesn't make the equation true, just circle no, and you don't have to do anything with it. Does that sound easy enough? Everyone understands? Are there any questions? No question? Okay, so to get full credit, you just want to circle every single yes or no. Don't forget to circle it. If it makes it true, circle yes. If it doesn't, circle no. Make sure you plot the point if it is yes. And explain your reasoning. So in math, a lot of times when we say explain your reasoning, you want to just show your work. Show that you actually plugged the coordinate point into the equation. Does everyone understand that? If you don't do those things, you'll get a 2 or a 1. Sounds good? Okay, great. I'll see everyone tomorrow with their homework.